In this video, we're going to talk about angles and their measure. Some key vocabulary when we talk about angles are the following. So every angle starts from a vertex. So that's this point right here that contains the two sides that make up the angle. So the starting side is called the initial side, and then wherever it terminates or ends is called the terminal side. So if I draw an angle in standard position, it would start here, and then if it's positive, it's going to go up, and I indicate that with an arrow where the angle is, and I name the angle. And then if I start here on the initial side and I go the other way or clockwise, that's going to be negative. And I can also create an angle that's greater than 360 degrees by just continuing that angle around, hitting the initial side and going through it once more. So that's positive, and it's still in the same counterclockwise rotation. It's just going to be greater than 360. For our intents and purposes, we're going to talk about angles that exist in the XY plane. So that's in our 4-quadrant system of quad 1, 2, 3, and 4. And it goes counterclockwise. So if I start on the initial side, or this x-axis here, that's at 0 degrees. And if I go up to the y-axis, that's 90. And then if I keep going, I go to 180, 270, and back to 360. Those angles are what we call quadrantal angles because they hit on the intersections between each quadrant. So they don't lie in a quadrant, they are on the axes. So now on to some more riveting things. Let's draw the following angles in standard position. So let's start with this first one. Let's draw 45 degrees. First thing I'm going to do is draw my vertex and then extend out my initial side. And I always put an arrow on that to indicate that it's an angle and it's a ray that'll go on forever in one direction. And then next I draw the terminal side. And if it's not perfectly 45 degrees, it's not the end of the world. And the last thing I'm going to do is indicate the direction and label my angle. And that's how you draw an angle. So let's do it for negative 90 degrees. So instead of taking my initial side here and going counterclockwise, I'm going to go clockwise to indicate negative 90. And 90 is a quadrantal, so I'm actually going to end up on the y-axis. And here's what negative 90 degrees with my initial and my terminal sides. And I turned this kind of round arrow thing into a square because if you draw a square, that means a 90-degree at right angle. You don't have to do that, but if you want to be fancy, you can do that. So let's do 2 more of these for good measure. Sorry. So let's try 225 and 405. Now those are both positive, so I'm going to start with 225 and draw my initial side. So once I've done that, I have to figure out what quadrant 225 is going to terminate in. So it won't be 1 or 2, but it'll be 3 because 225 is between 180 and 270, and let's draw that out. So here you have it. I draw my arrow to indicate that it's positive and I label it. So let's do 405. It's positive, it's going to have an initial side here, and it's going to have to go around at least once. So to figure out how much more it has to go, I do 405 and I subtract 360 from it, and I see that it has to go an extra 45 degrees. So let's draw that. So I start with my initial side, and then I know it'll go around once and keep going 45 more degrees, and I put my arrow going this way to indicate a positive angle, and I label it, and there you go. Something else that's really important when we talk about angles is the measurement of them. So I know that you're familiar with degree measurements, but there's also another type of measurement, and that's called a radian. So in this image of a circle, or in our 4-quadrant system, you see degrees, so 0, 90, etc. But you also see something next to it, like 0 or pi over 2 or pi, 3 pi over 2, and 2 pi. Those are in terms of what we call radians. Now, what is a radian, you might ask? Let me try to explain. So let's say I draw a circle with radius length r. And I take that radius and I stretch it to fit the arc outside of that circle, and then I call that 1 radian, or for radius. I move it again, I get 2 radians, 3 radians, and pi number of radians, or 3.14. That's why there's a pi over here where there's 180. And if I double that, I'm going to get 2 pi radians, or 360 degrees when I go all the way back around. So what that means in terms of translating between degrees and radians is that pi, so in terms of that circle over here, pi is equal to 180 degrees. So as a ratio, we get pi over 180. And if I'm converting between radians and degrees, I just switch that to be 180 over pi. So let's see what that looks like in action. So let's work on converting something we know, degrees, to something we're less familiar with, which is radians. So let's take a couple examples. The first being 60 degrees. So in order to convert degrees to radians, I multiply by pi over 180 because I'm looking to have a pi in my answer typically, although you couldn't have radians without a pi in it, just so you know. So what I'm going to do is I'm going to simplify the 60 and 180 to pi over 3 radians. So let's look at another example of 150 degrees. Going to do the same thing, multiply 150 by pi over 180 and simplify. And I'm going to get 5 pi over 6 radians. So let's do 2 more of these just to make sure we get the hang of it. So let's take a negative angle of negative 45 degrees. And I'm going to do the same thing, multiply by pi over 180, and I get negative pi over 4 radians. That negative's important. Now let's do 1 more, and that's 315 degrees. And not shockingly, I'm going to multiply 315 by pi over 180, and I get 7 pi over 4 radians. And now let's work backwards, converting radians to degrees. So even if this example, pi over 6 radians, didn't say radians right here, I would know that it's in radians because it's got a pi in it. Normally degrees are not expressed that way. So what I do here is I take pi over 6 and I multiply it by 180 over pi because I'm trying to get those pi's to cancel each other, and I simplify. And what I get is 180 divided by 6, which is 30 degrees. Don't forget your degree symbol. So let's do the same thing with 3 pi over 2 radians. I take 3 pi over 2, I multiply it by 180 over pi, going to cancel what I can. So I cancel my pi's, and I'm actually able to reduce 180 over 2 to 90. So 3 times 90 is 270 degrees. All right, 2 more. Let's convert negative 3 pi over 4 radians to degrees. I set up my multiplication by 180 over pi. Next, I'm going to try to cancel. So the pi's go away, the 180 over 4 turns into just 45, and negative 3 times 45 is negative 135 degrees. So last example is converting 3 radians without a pi in it to degrees. Going to do the same thing. I have a 3 here times 180 over pi. And I'm going to get 540 over pi, and this is where I need my calculator. So I'm going to use the pi button. And that's going to be about 3.14, that value of pi. And so if I do 540 divided by pi, I get about 171.887 degrees. And that's going to do it for this video. Thanks for watching.